Today on the Perception in Action podcast, a look at the extended challenge point hypothesis. How can we get the level of difficulty right to challenge a performer? What are 3 different goals coaches might consider when designing a practice? So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Before we get to today's topic, I want to tell you about my new book. Yes, I've written a new book on skill acquisition called How We Learn to Move, a Revolution in the Way We Coach and Practice Sports Skills. It covers the ecological approach to skill from different angles, including practice design, the CLA, coaching, youth sports, designing technology, injury prevention, and using analytics. So I hope you will consider giving it a read. You can find the book on Amazon or by going to perceptionaction.com/book. Now on to the show. In today's episode, I want to look at the really interesting new paper by Nikki Hodges and Keith Loesch. This paper builds on the well-known challenge point hypothesis, which I first discussed back in episode 105. As the authors note in their paper, I think most people really like the challenge point ideas. However, it's not always clear how you go about actually applying them. For example, how do you really know what the nominal and functional difficulty are for different practice tasks? Nikki and Keith try to address this by expanding on the original work in 3 different ways. First, the authors seek to achieve a balance between challenging the performer, which involves creating a practice environment where they're going to make mistakes, and keeping them motivated. Quote, with respect to application, we must recognize that although difficulties or challenges in practice can be beneficial for learning, such challenges can also have motivational costs. These costs are a product of introducing more errors into practice and performance. There's a vast literature linking perceptions of competence and motivation to performance, particularly in sports. Reduced motivation has negative effects on learning because learners may stop practicing sooner. End quote. Second, the authors make the critical point that not all types of challenge are effective for learning. Specifically, practice needs to be designed with difficulties that create new information for the performer. Quote, a second point regarding the challenge point framework in coaching is that not all difficulties are equally beneficial for learning. It is not difficulty in and of itself which is good for learning, but the psychological processes which are engendered by the difficulty. These type of process difficulties have been termed desirable because they beneficially enhance encoding of information and its retrieval. End quote. So clearly, the authors are taking an information processing view of learning throughout the paper. In particular, they point to the concept of predictive coding. I haven't really talked about this too much on the podcast yet, but it's the idea that you can actually trace back to Richard Smith's schema theory that when a performer plans an action, they try to predict the sensory feedback they will receive from the action. If there is a discrepancy between this prediction and the feedback you actually get, that is information that can be used to revise the motor plan or program. To again quote the authors, this helps us to situate the framework with other psychological theories in terms of the individual as a predictive system who learns when information expectations are violated. End quote. I will return to this later and talk about how we can conceptualize these same ideas in an ecological framework. Finally, the author's third point is that the optimal practice difficulty for an individual performer is always dynamic and changing. Quote, our third point regarding the coaching implications of the challenge framework is that the dynamic nature of the competitive environment makes the optimal difficulty for an individual or team a moving target across practice sessions. The difficulty of a particular practice scenario can change in the short term, perhaps due to fatigue or arousal, as well as over the long term as a result of learning. Moreover, goals of practice may change, such that at times it may be beneficial to practice with high functional difficulty to optimize learning and improvement. At other times, it may be beneficial to practice with lower relative difficulty, reinforcing success and promoting competence. We elaborate on and provide evidence for each of these issues below, but ultimately we suggest that coaches can manipulate functional difficulty, motivation, and specificity to optimize different practice goals. End quote. So capturing the idea of periodizing skilled training, like I've discussed in previous episodes. Relevant to this last point, the authors identify 3 different goals for practice. Practicing to learn, that is forsaking short-term performance with the goal of long-term learning. Practicing to transfer, That is, maintaining high levels of difficulty and specificity to facilitate transfer of acquired skills to competition, and practicing to maintain, reducing the difficulty to retain existing skills and growing athletes' perceptions of their own competence. I will discuss these ideas in a little bit, but let's dig into some of the more specifics of the paper first. As I mentioned at the start of today's episode, one of the main goals of this paper was to elucidate how the challenge point framework can be applied. To achieve this, the authors highlight three main parts of the hypothesis. Quote, "There are three basic principles related to the challenge point framework that can be used to design practice. The first is that new information, or a degree of uncertainty, is needed in practice for long-term improvements in the current level of skill. In this way, learning is a problem-solving process where information is used to adapt behavior and learn over the long term. The second principle is that an optimal level of difficulty or challenge is needed to get this information based on pre-existing capabilities. It is not merely new information, but usable information that is needed. A learner's information processing capabilities limit the amount of potential information that is interpretable. That an appropriate level of challenge is dependent on the athlete's skill and experience and their information processing capacity relative to the demands of the task." End quote. This is where the authors bring in the distinction between nominal and functional task difficulty from the challenge point hypothesis. A task nominal difficulty refers to an objective, performer-independent assessment. For example, shooting a jump shot in basketball from 20 feet away would have twice the nominal difficulty of shooting one from 10 feet away. Functional difficulty is with reference to a specific athlete. So while a 20-foot jump shot may be twice as hard as the 10-foot one for an experienced adult player, it could be 10 times harder for a child just learning to play because they don't have the strength and coordination solution to get the ball to the hoop from very far away. The authors also note that it is important to consider the perceived difficulty of the task from the athlete's perspective. For example, see the work of Wolf and colleagues showing how expectations for success can influence motor learning. The authors also make a very important point in their paper regarding a performer's ability to assess the degree to which they're learning and improving in different conditions. For me, this is related to a comment I frequently get, that isolated, decomposed practice drills should be used because some athletes like and prefer them over more variable coupled activities. Well, what we like is not always what is good for us. Nikki and Keith make this point nicely in talking about research on random versus block practice. Quote, "What is particularly interesting about these practice order effects is a sense of fluidity and apparent feeling of learning which accompanies people who practice under repetitive, drill-like block practice conditions. Fast gains in practice give the impression that learning is taking place, even though faster acquisition is not necessarily good for long-term learning. When participants who study under block conditions are asked how well they will do at a future time, they show optimism in their retention capability, compared to people who study under random conditions. This sense of learning, which accompanies rapid gains in practice, is despite data gathered from retention tests, which show the opposite pattern." End quote. Even though an athlete may like and feel more confident when a coach implements things like repetitive, isolated practice drills and prescriptive instruction, telling them exactly what they should be doing, the research clearly shows that these are not the best conditions for actual learning and transfer to other conditions. The authors emphasize the importance of challenging the athlete. Quote, "In general, more challenge equals worse performance and less challenge equals better performance. When learning is considered, however, a different relationship is conceptualized. When there is little to no challenge, then there is little to no learning, which we refer to as a comfortable difficulty. This does not mean that there is no difficulty or even low difficulty, just low difficulty relative to an athlete's current skills. As relative challenge difficulties start to increase, this is where learning starts to happen. Importantly, this relationship between challenge and learning is not linear, but is considered to be an inverted U-shape, whereby too much challenge is also bad for learning, what we refer to as punishing difficulty." End quote. So a few key points. We need to challenge the performer, resulting in them making some mistakes for learning to occur, but we can't push it too far. Too high a level of difficulty is just going to lead to chaos. I should also note in the paper that the authors also include some really great figures to illustrate these ideas. They emphasize that practice difficulty should be in the optimal zone for learning, which they define as the point at which there begins to be some decline in performance, but not too far beyond that. This seems to fit nicely with the advice I always give people when asked this question. That is, you should be aiming for about a 75 to 80% success rate in performance. So some errors, but not too many such that the performer loses motivation and or cannot use the feedback from their performance to learn. The authors also make another point that I like to emphasize. That is that challenging an athlete is not just designing a practice activity and standing back and doing nothing. Quote, in order to help make this new information usable, the coach often provides a valuable role in helping direct attention and determining key information. This help may be through the adapting of task-specific constraints, changing rules, or augmenting practice through verbal instruction or video, end quote. Practice should be iterative and adaptive based on how the athletes are performing and taking or sometimes not taking the opportunities you're providing as a coach. Along these lines, the authors also emphasize the need to adapt and increase task difficulty as performers improve. As an athlete gets better at the task, the amount of new information they get from practice activities is going to decrease, so we need to keep pushing them to create new opportunities to learn. The authors again conceptualize this in a predictive coding framework. Quote, when we act, there is thought to be a corollary of this action plan, termed efference copy, which enables forward model predictions about the action's expected sensory consequences operating largely outside of awareness. Expectations and forward models improve with practice, and we become better at generating accurate predictions about how a movement will feel, look, or sound. Under conditions of uncertainty, information is sought and attended because it is new or unexpected and gives value to the performer. In the challenge point framework, this uncertainty was linked to both the action plan, what to do, as well as the sensory consequences. What will happen? How will it feel? When there's uncertainty in what is being performed, information matters and opportunities for learning are enhanced. End quote. So in other words, when everything is highly predictable and expected in a practice session, there's no new information available to guide learning. In my experience, this is the case for a lot of the activities we do. Baseball batters attempt to hit balls where they swing at every pitch and the pitch is highly predictable. In predictive coding, we would not expect many instances where their expectations about their feedback they should receive are violated. Finally, in this section, the authors address the issue of motivational costs associated with challenging an athlete. In doing this, they make a critical point that I think I say in all of my talks now. Quote, we also need to consider the potential motivational costs of errors for both the learner as a person with psychological and safety needs and for learning as a psychological process. One step that is likely to be important for this balance is creating a culture where athletes feel comfortable exposing their weaknesses, performing under novel conditions where successes are not guaranteed, and engaging in practice conditions which are challenging. End quote. The authors make two specific recommendations for how this might be achieved. First, using self-comparisons to reduce social competitive pressure, and second, progressively increasing difficulty as performance improves. This is something I've talked about back in episode 165 when looking at adaptive training, which research has shown to be highly effective. In the final part of this paper, the authors discuss in detail the three proposed goals of practice. And this is what I really want to focus on today. If you recall, the three types of practice they propose are practice to learn, practice to transfer, and practice to maintain. First, let's look at practice to learn. To quote the authors, the basic idea about practice to learn is that the athlete or coach needs to be comfortable sacrificing performance or parts of performance in practice in order to maximize learning and improve. For a more competent athlete, performance will shift from a place of stability, good performance, and comfort to a messier place so that learning can take place. This is achieved through increasing challenge and the creation of new opportunities for new information. Because there are fewer opportunities to learn and gain new information at higher levels of skill, creativity is needed from coaches and players to engineer situations that create the opportunity for learning and growth. End quote. Contrast this with the way the authors define practice to transfer. Quote, here, challenge is matched to expected gain demands. Practice should have aspects that mimic difficulties and challenges expected during competition at both the individual and team level. Considerations for optimal challenge are to find the point at which transfer to the game will be greatest. The focus should be on creating meaningful difficulties which match behaviors and processes required in competition. There are many ways that these game day challenges can be conceptualized, but the most common aspects relate to the mimicking psychological and physiological states, such as increased self-evaluation, competition, attention demands, and fatigue. Other external environmental factors could also be considered for this type of practice too, such as crowd noise, which may make it hard to communicate, or weather, playing surface, or visibility. End quote. So there are two main differences here. From the figure captions in their paper, Practice to transfer involves high difficulty and high specificity to competition, while transfer to learn involves moderate difficulties with, quote, at least moderate specificity to competition. This is where I have a bit of an issue with this paper. I don't find this distinction very useful, in particular in terms of how specificity is considered. What does at least moderate specificity mean? How do I know when I've got it? This can be seen in one of the examples the authors give. Quote, there may be situations where learning goals are designed to reveal new information, with only minimal consideration of practice specificity for transfer. For example, requiring a player to play a new position not usually experienced, such as a batter practicing pitching, or observing actions from a new perspective, introduces new information for learning. End quote. While I understand the idea the authors are getting at with this example, that seeing the other side of the hitter-pitcher interaction can be beneficial, there are some problems I see. First, the vast majority of baseball position players have not pitched competitively in a very, very long time, if at all. So the level of challenge associated with having to pitch against another highly skilled hitter would be enormous. Yes, there would be a lot of new information there, as the authors say, but in this practice session, that information is used to pitch, not hit. In fact, a lot of baseball teams do recognize that having a different perspective could be beneficial, but they approach it in a much different, more specific way. For example, some teams have pitching coaches run the practices with hitters, but while they're hitting, not pitching. They also do things like having batters hit from on the non-usual side of the plate or hit cross-handed. So yes, they're doing things we wouldn't do in competition, but they're not asking their hitters to do a completely different task. And just how far can we push this practice to learn? Would being an umpire for a day help a hitter? How about playing MLB The Show on PlayStation? Hitting involves perceiving moving objects, so would doing Neurotracker help? What about trying a completely different sport that involves swinging an implement, maybe golf or tennis? What are the criteria for specificity that separates transfer and learning? How do we know when we have the conditions for learning? Is any type of learning okay? For me, the only way we can know whether or not we have appropriate conditions for learning in sports is by what? Assessing transfer of training. Let's look at Neurotracker, for example, because if I understand correctly, it would fit in the author's practice to learn category here. People definitely learn something when they train with Neurotracker. They get better at doing Neurotracker. And if we subscribe to an information processing view, the things they learn should be part of what's involved in skillful performance. The general abilities of motion perception, working memory, selective attention, etc. But as Christian Vader, Alex Holcomb, and I showed in our systematic review we published last year, there's no evidence at all that training with Neurotracker helps improve sports performance. I've linked to our paper and another recent one that failed to replicate the one study that has shown transfer with Neurotracker in the show notes. To justify the use of things like Neurotracker, although they don't mention it specifically, the authors of this paper bring in the idea of scaffolding from education research. The idea of scaffolding as it applies here is that while what you're learning right now might not get you to your end goal directly, it can help give you a foundation which makes future, more challenging specific practice beneficial. Stated another way using the terms from the paper, if we do practice to learn, where you use Neurotracker with generalized stimuli designed to improve your selective attention and working memory, this should provide a scaffold on which practice to transfer in the specific sport will be more effective, because it's assumed that these general perceptual motor abilities are involved in sports. Or using their other example, a position player in baseball practicing learning to pitch could provide a scaffold that may make more specific hitting training more effective, presumably by giving them a better strategy on how to beat the pitcher. My problem with these ideas of practice to learn and scaffolding, other than the fact they're built on a modularized, indirect view of skill, is that they seem unbounded to me. Is playing chess a scaffold for being a football quarterback? There seems to be virtually an unlimited number of things we could do that would fall into the category with at least moderate specificity to competition. How do we know what will and won't provide an effective scaffold? How do we know what will be an effective use of practice time? The way we know these things is by assessing transfer of training. In my opinion, all training must be with an eye towards transfer, or what are we doing? Appealing to the ideas of practice to learn and scaffolding seems to me in some ways to absolve people from the burden of proof, because we show learning in literally everything we do. Really, what is the real difference between playing MLB The Show video game and doing Neurotracker, other than the latter was developed by scientists? For me, the concept of representative learning design provides a much more precise way of manipulating specificity and challenge in practice than creating binary categories of practice to learn and practice to transfer. In representative learning design, improving performance in competition is always our goal, but that does not mean we have to always perfectly mimic the competition. We sample or take a slice from the game. That is, we decrease specificity and difficulty in a purposeful way to help the learner explore and exploit movement solutions that will help them in the game. But there are clear guidelines for how we do this. Reducing the difficulty from high to moderate is done through task simplification, not decomposition, like I've discussed many times. And when we decrease specificity, we always aim not to break some aspects of the skill. For example, we try to maintain action fidelity, perception-action coupling, and ensure the information available to the performer is similar to that available in competition. Some of the other examples the authors give when discussing practice to learn nicely fit with this. Quote, uncertain conditions not only serve to keep the performer actively engaged in the learning process, but also provide practice opportunities for events that mimic some of these encountered during competition, where vision may be blurred or obstructed, or playing surfaces are damaged or uneven, causing balls or pucks to travel in uncertain ways. This novelty can be achieved through changes to ball size, field size, or surface, end quote. So basically, we're talking about constraints manipulations here. So all of this is not to say that I think you don't need different goals for different practice sessions as a coach. But for me, all of our goals should be based around achieving transfer to competition. Otherwise, we're not using practice time as effectively as we could. I understand the author's motivation with creating distinct categories based on high, medium, and low levels of difficulty and practice specificity. But returning to the point the author started the paper with, I don't think functional difficulty and specificity can be defined precisely enough to support the idea that we cross into a completely different purpose. For example, from transfer to learn. For me, playing a small-sided game in soccer is not something fundamentally different from playing the match, with the former being learning and the latter being transfer. The small-sided game is just a purposely chosen sample or slice of the competition, with decreased difficulty and decreased specificity guided by the principles of representative learning design. As I mentioned, I think having, quote, learning something under moderately specific conditions be the goal of practice is too unbounded. I think it's much better to think of the goals of practice in terms of representative learning design and the model of periodization developed by Audie and colleagues I discussed in episode 168 and 181. Finally, I want to consider how we might conceptualize challenge and ecological approach to skill. As mentioned, Nikki and Keith frame their paper in terms of predictive coding, and the idea that the information that drives learning is discrepancies between our predictions about sensory feedback and the actual sensory feedback we receive. As proposed by Schmidt in schema theory, this discrepancy is used to modify the action plan or motor program for the next execution of the action. For example, if we receive more force than expected when our foot contacts the ground, we would presumably change the force parameter in our motor program. What I really like here is the author's approach of trying to quantify challenge in terms of information available to the learner. It gives clear logic to it and guides a coach in choosing what types of challenge are going to be relevant. However, I would, of course, think about information in a totally different way. I'm going to try and devote an episode to predictive coding in the future, but to be honest, I'm not clear why everybody on the indirect perception information processing side has gravitated toward it. To me, it seems to have all the same problems associated with motor programs and internal models. And to my knowledge, there's no specific example of predictive coding applied to any sports skills. But anyways, I'll try to dig deeper on that in the future. From an ecological perspective, there are two concepts that provide a way to think about the information that guides learning that I've talked about in previous episodes. The first is the idea of information for learning in the theory of direct learning proposed by Jacobs and Michaels. As I discussed in episode 53, this is similar in some ways to what Nikki and Keith are proposing, but the discrepancy is not based on a prediction, but rather lies in the information picked up from the environment. To quote from my previous episode, so learning involves movement through information space. What guides this movement? As is true of all theories of motor learning, the process starts with some error or non-optimality in performance. If we are performing the task successfully, there's no reason to change anything. But how does the performer know why an error occurred? For example, is it due to non-optimal calibration, or is it the result of attending to a variable that cannot actually be used to achieve the desired result, what in the ecological approach is called a non-specifying variable? Do we need to appeal to some high-level monitoring process to solve this? The second key concept of direct learning theory solves this problem: information for learning. The idea is that in our environment, not only is there perceptual information that we can use to guide our actions, but there's also perceptual information that specifies how non-optimalities in our performance can be reduced. In other words, there's information related to the difference between the currently used variable and the optimal one. This difference is information for learning, in that it indicates the required path of movement through the information space. The specific path learning takes depends on both the local constraints and where they start in the information space." End quote. In a future episode, I will try to elaborate on this a bit by reviewing David Jacobs' studies to give some specific examples. The other concept that can be applied here is Newell's transition feedback, which I first discussed in episode 171. To quote Newell, "Transition information is that which specifies a to-be-achieved property of a coordination and control solution that should be searched for in the upcoming movement trial. But in the act of realizing that goal, a transition to another coordination control solution emerges. Thus, transition information is not prescriptive information in that it's not prescribing the to-be-achieved end-state dynamics of the to-be-learned movement skill. And it's not information feedback in that it does not provide information about past movement states and their goals realized. Rather, it provides information more directly about the change in movement coordination and control than either prescriptive or feedback information. Theoretically, transition information may be viewed as a control parameter that facilitates the search through perceptual motor workspace for the realization of a task-relevant coordination and control solution, and it may appear unrelated to the to-be-achieved end-state dynamics." End quote. My favorite example of transition information, which I discuss in detail in my book, is the connection ball in baseball pitching. The direction the connection ball goes when it falls out gives direct information from the environment without any need for prediction or processing that tells the athlete about their search for a new, more effective solution. So in sum, I think this paper is a much-needed expansion on the challenge point hypothesis that I definitely would recommend everyone read and have a think about. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep them coupled.